Right, we're going to look at the binomial distribution. And binomial distribution, what happens is we look at events or outcomes where there's two possible outcomes. We have one where there's a probability that you can have a successful outcome, and you also can have an outcome which is not successful. We'll call it failure. And the probability of the successful outcome is p, and the probability of the unsuccessful outcome therefore must be 1 minus p, because those are your two possible choices, either success or failure. From this we can tabulate our results. We can have x is going to be our number of successes. Well, we can either have 1 success or 0 success if we have just one trial. Just going to look at one trial, and we're going to look at the probabilities that can occur. So the probability that we get our random variable x equal to x for 0 is going to be 1 minus p, and for 1 is going to equal p. So let's look at two trials. So again, we have success and failure for the first trial, and you've got p and 1 minus p as your two probabilities. And we can have success and failure for the second trial. So given that we were successful the first time, we could be successful the second time, p as well, and 1 minus p. So what we are saying is our first condition was you can have two outcomes, success or failure. The second condition is the probability doesn't change, and consequently in this case that they're independent of each other. Alright, these probabilities are independent of each other because the probability of success followed by success will be equal to p times p, which is p squared. And there's just one way that we can get success followed by two successes. Yep. There's just one way we can get two successes. So I'm going to write down the number of successes here as being 2. So the number of successes is 2, and its probability was p squared. Now here we've got success followed by failure, so the number of successes we had here was 1, and the probability is going to be p times 1 minus p. Here we've got success after a failure, still probability of p. This is one success, and the probability is going to be p times 1 minus p again. But a failure followed by a failure, if that's going to be p for success, is still going to be 1 minus p, so 0 failures will give us 1 minus p squared. That's 1 minus p times 1 minus p. So if we look at our possible values, when we have two trials, we can have either 0, 1 or 2 successes. So we're letting x equal the number of successes. So the number of successful outcomes. So the probability that x equals x, where there's 0, there's 1 minus p squared is our probability. When we have one success, there's actually two ways we can get this. And both of those properties are exactly the same. So each time we had p times 1 minus p, but there's two ways we can do that. So we times that by 2. And with two successes, there's only one way you can get that, and it's p squared. So note the number of ways that we can get this. It's 1, 2, 1. One way we could get that, two ways you can get that, one way you can get that result. If we go back here, there was one way we can get that, there was one way we can get that. 0 result, 1 result, there's only one way for each. I wonder if you can spot a pattern occurring. Right, let's look at 3 trials. So let's put in our success and failures everywhere, and the probabilities that go with them. Now here we have 3 successful outcomes, and the probability of that occurring was p cubed, p times p times p. Here we have 2 successful outcomes, and we've got p times 1 minus p, so that gives us p squared times 1 minus p. Here again we have 2 successful outcomes. We've got a p squared times 1 minus p again. What you'll notice when we have a certain number of outcomes, and the probabilities of them occurring is the same. One successful outcome, so we've got p times 1 minus p squared, because you've got 1 minus p times 1 minus p. 2 successful outcomes, p squared times 1 minus p. Here we go, one successful outcome. So we got p times 1 minus p. And here we got one successful outcome. And again, p times 1 minus p. Sorry, I forgot the squared there. And here we've got no successful outcomes. So it's just 1 minus p cubed. So let's put that all into a table now. So here we've got x. And we've got 0, 1, 2, 3 successful outcomes, and the probability of each occurring. So 0, it was just 1 minus p cubed, and it's the only way we could get it. There's no other way of getting no successful outcomes. There were 3 ways of getting one successful outcome. All of them had the same probability. So 3 times p times 1 minus p squared. 2 successful outcomes. There was 1, 2, 3 ways, and all of them had the same probability gain. So 3 times p squared times 1 minus p, and there's only one way of getting 3 successful outcomes, and that had a probability of p cubed. So note again, 1, 3, 3, 1 as our number of ways. So if we go back to this, let's look at no trials. Well, there's no successful outcomes, there's nothing that can happen, there's only one way. Okay, it's dead certain that we're going to get no successes. If we have one trial, then we're going to have 1 and 1 as a number of ways. You can have 0 successes or 1 success. If we have 2 trials, we can have 1 lot of 0 successes, 2 lots of 1 success, and 1 lot of 2 successes. 3 trials, and we can see the number of ways of getting the different success outcomes was that. And we can see that these are just binomial coefficients from Pascal's triangle. So therefore, if we have n trials, our successful outcomes, p is equal to the probability of success. Therefore, the probability that x is equal to r number of successes is going to be equal to the coefficient, which is given by the binomial theorem, NCR. Some of you may have seen this as NR like this. Doesn't matter which way you write it. And then we've got to times by the probability of success. And how many successes do we have? When there's 0, we have p to the 0. When there's 1, p to the 1. 2, p to the 2. 3, p to the 3. So it's just going to be p to the r. And each time we times by, so that shouldn't be a square, that should be a cube there. There were 3 failures, so it's 1 minus p to the 3. 2 failures, 1 minus p to the 2. 1 failure, 1 minus p, and then we've got 1 minus p to the 0. So we take the r away from n. So 0 away from 3 gives me 3. 1 away from 3 gives me 2. 2 away from 3 gives me 1. And 3 away from 3 gives me none. And we make that the power for our probability of failure. And just copy this in below so we can see that these are the 2 ways that you may be used to seeing this written out. And this is our formula for binomial probabilities. So this will give us the probability of x equaling r number of successes from n trials with a probability of success equal to p. And you just put your values into this formula. In the next film I'll go on to do an example, and I'll also go on to look at the mean and variance of a binomial.